In this video, we're going to continue topic 6.1, and we're going to be looking at example 27. We're still doing some U-substitution here. So we're going to let f be the function such that from -2 to 0, f of u du equals 10. So what must be the value of -4 to 0 of f of 1/2 of x dx? Not knowing what else to do, I'm just going to try using a little U-substitution here. So I'm going to use my u equal to 1/2 x, which means that du is equal to 1/2 dx. I notice that I have a 1/2 that I don't have here, so I'm going to put a 1/2 there and a 2 out in front. Okay, and then we're going to go ahead and actually do our U-substitution in step. So I know that I'm putting a u in for the 1/2 x, and then for the 1/2 dx, I get to substitute in the du. And then I know I need to change my bounds. So my lower bound, I'm going to substitute in. So for x equal to -4, I'm going to plug in. I get u equals 1/2 times -4, which is going to be -2. And then I'm going to plug in my 0. So for x equal to 0, I've got u equal to 1/2 times 0, or just 0. And I happen to notice that this is the same as this, so I know that it's equivalent to 10, and I can substitute a 10 in and just drop this 2 down. So what do you know? I'm evaluating actually what it equals. It's actually equal to 20. All right, let's take a look at example 28. So in example 28, it's a little bit different, a little bit more weirder AP-esque. We're going to be given that g prime equals f of x, with g of 4 equal to a, g of 5 equal to b, g of 13 equal to c, and g of 14 equal to d. And we are so supposed to express the value from 3 to 6 of x times f of 1/3 x squared plus 2 dx in terms of a, b, c, or d. So basically, we need to integrate this thing. We're probably going to be using some U-substitution, and we're going to have weird answers that look like A, B, C's, and D's. So let's take a look at it. So this thing here is going to be our u, okay? So u equals 1/3 x squared plus 2. That means that du is equal to 2/3 x dx. So I don't have the 2/3, so I'm going to rewrite a little bit to make it bigger. So we're going to go from 3 to 6 of x f of 1/3 x squared plus 2 dx. Okay, we know this is the u. We know we've got an x dx, and I have to add in a 2/3, which means outside I'm going to add in a 3/2, because 2/3 times 3/2 would be 1. So I'm not changing it in any way. All right, we're going to rewrite. So we've got 3/2. I'm going to do my substitution in. So my orange is going to become the u, and then the blue part is all going to become the du. I now need to change my bounds. So 3, I'm plugging into u. So x equals 3. I get u equals 1/3 times 3 squared plus 2. Well, 3 squared is 9. 3 goes into 9 3 times, plus 2 is 5. So my new lower bound is 5. My upper bound is 6. So I'm going to go x equals 6. So u equals 1/3 times 6 squared plus 2. 6 squared is 36. 3 goes into 36 12 times, plus 2 is 14. So there's my new equation. I'm going to go ahead and integrate it. Actually, I'm going to substitute a little bit first. It tells me, okay, that g prime is equivalent to f of x, meaning I could plug in I'm going to plug g prime in place of f, which makes more sense because I don't know how to integrate f of u, but I do know how to integrate g prime of u. So g prime of u du, and AP likes to do that. They like to switch it up on you. So when I integrate g prime, I get back to g. We're going to go from 5 to 14. So we're going to go ahead and plug those in. So 3/2 g of 14 minus 3/2 g of 5. Well, they did tell me g of 14 equals d, and g of 5 equals b. So I have 3/2 times, it was d, minus 3/2 times b, which is a perfectly good answer. I could also have left the 3/2 out front and gotten an answer that looks like that.